Do you know that many everyday devices which rely on radio, such as car doors or drone systems, can actually be hacked wirelessly if they're not secured properly? And the key to doing all this lies in something fundamental called software-defined radio. Software-defined radio is basically the name of a technique, which utilizes some kind of a special hardware and software to capture any type of radio frequency around them. And in this video, I'll walk you through the different ways hackers can use this technique to exploit multiple everyday devices. So let's get started.
Disclaimer.
This video is intended for cybersecurity enthusiasts and is for educational or awareness purposes only. It is documentary in nature and does not provide step-by-step guide on how to exploit radio devices. Black hat hacking is highly discouraged and can result in serious legal consequences.
Chapter number 1, Hardware and Software Used for SDR.
Okay, so now that you know SDR is a technique that uses hardware and software to capture any type of radio frequency around them, the question is, what kind of hardware or software makes this possible, and how can it be used effectively by hackers? Well, that's exactly what I'll be covering in this chapter, walking you through some of the popular SDR tools, explain their purposes, and show you how they can open up a world of endless possibilities. So let's start.
Tool number 1, RTL-SDR.
RTL-SDR is a simple SDR dongle that anyone can buy on Amazon for about $30 to $40, and it's primarily used by hackers to eavesdrop on insecure radio communications in a vicinity using a tool like SDR Sharp.
10-4 over, we have a bar fight, seems to be two guys in a verbal dispute.
SDR Sharp is basically a software that helps in both finding and listening to the radio frequency a target is communicating at, and so after a hacker identifies the right frequency, they can simply adjust the RTL-SDR's antenna to match it, plug the dongle into their computer, and open the SDR Sharp software to eavesdrop on their communication. Now you might be wondering, why is this even possible, and shouldn't these communications be hidden or encrypted? Well, yes, but the reason why such things are left insecure is either because encryption defeats their purpose, like in the case of air traffic control system, where pilots and towers need open communication for safety and efficiency, or because encryption adds additional costs and complexity that many government agencies or private sectors avoid, leaving their communications exposed for anyone with the right tools to listen in. But here are a few important points. Firstly, if these communications were encrypted, a hacker couldn't just capture and listen to them so easily. They'd need to break through the encryption first, which can be challenging depending on the encryption standard. And secondly, while RTL-SDR is a great tool for receiving or eavesdropping on communications, it doesn't allow a hacker to transmit or send out malicious radio waves in order to exploit a device or hack it. And this is where the second tool that we'll now discuss comes into play. But before we get into that, I'd like to thank the sponsor of this video, Any.Run. Exploiting vulnerabilities isn't just limited to the wireless world, but is also a major threat in the digital space, and that's where tools like Any.Run come into play. Any.Run is a cloud-based sandbox that lets you analyze how a malware operates by running it in a controlled environment, and unlike using traditional virtual machines, it offers some unique advantages, such as securely isolating threats to prevent malware from escaping into your network, or providing access to a vast library of samples to choose from. Its interface is designed to be beginner-friendly while remaining powerful enough for experts, and includes various tools that let you view all the network connections a malware is making, or the commands it is executing. What makes it even better is its teamwork feature, allowing a team to efficiently collaborate in a shared workspace, or the safe browsing tool, which lets you determine the safety of a website within seconds, and enabling you to decide whether to block specific entities or not. To try it out, you can visit their website, and sign up using your university or business email, to get the most out of this amazing tool at an unbeatable price. Thanks for listening, let's get back to the video.
Tool number 2, HackRF One.
HackRF One is another SDR tool that, when paired with softwares like Universal Radio Hacker, or a modular add-on called Portapack, allows a hacker to both transmit and receive radio frequencies across multiple bands, and while it can be used for eavesdropping on communications like the ones we just talked about, its true strength lies in executing a range of other attacks that we'll cover next, and explore how they're performed. So let's get started.
Attack Vector 1, Replay Attacks.
Replay attacks are typically performed on RF controllers used to wirelessly lock or unlock things over a distance, and here, a hacker basically positions themselves near the targeted system, and waits for the victim to press their key fob in order to unlock it. When the victim presses the button, the hacker captures the unlocking signals transmitted between the controller and the receiver using HackRF One, and once the victim leaves the area, they can then transmit the same unlocking keys in order to gain access to the targeted system. Now, if you're interested in learning about the specifics of how hackers might do this, you can search on Google for more information. But for now, just know that while I used garage doors as an example, replay attacks can also be performed on a wide range of other devices, and to explore these further, you can download this table that I personally created by clicking on the link in the description down below.
A quick note.
Replay attacks are only effective on devices that use something called fixed codes for communication instead of using rolling codes. If a system is using rolling codes, a hacker may need to use the following techniques to get around them, and I'd highly recommend you exploring them further.
Attack Vector 2, Jamming Attacks.
Jamming attacks are one of the most simplest yet disruptive techniques in a hacker's arsenal, and here, a hacker basically transmits a continuous stream of noise on the same frequency that the two devices are communicating at, in order to block their connection. Now, while this type of attack can also be used to disrupt Wi-Fi or Bluetooth connections, interfere with walkie-talkie communications, or even target more complex systems like satellites, a point to keep in mind here is that jamming any kind of signal is illegal in most regions, and to avoid getting into any trouble, it's best not to attempt signal jamming unless you actually know what you're doing.
Number 3, More Attacks.
Okay, so now that we've covered some of the most common and widely executed attacks carried out using software-defined radio, here are some of the more specialized ones to help you understand what else is possible, and how these techniques can target systems you might have not considered before.
Tool number 3, Flipper 0.
Okay, so up until now, all we've talked about was either a receive-only device, which could target frequencies between the range of 500 kHz to 1.7 GHz, or a general-purpose device, which could target a range of frequencies within 1 MHz to 6 GHz. But what if you needed a device that was less expensive than the HackRF One, and could transmit or receive frequencies specifically between 300 MHz to 928 MHz? Well, that's where Flipper 0 comes into play. Flipper 0 is a relatively inexpensive device, designed to exploit systems operating on lower frequencies, and while it can perform the same types of attacks we've just talked about, its true strength lies in its beginner-friendly and intuitive interface, with a support for other protocols like NFC, RFID, and infrared. Thanks to its incredible popularity, Flipper 0 also has an active community creating custom firmware and mods to enhance its capabilities, making it easier to find tutorials and discover new ways to use the device. Anyway guys, so that's it for the video. If you have any questions, feel free to ask them in the comments section down below, and I'll see you in the next one.